Hello everyone, here I come with more problems on functions. We had some sessions before. I hope all of you are enjoying those sessions, and please just do not enjoy only. Start solving also. Unless you solve the problems, nothing will come for your help. No video sessions, no book, no solved examples. Only unsolved examples. When you solve, you will get hold, right? So let us start. The question is, function f and g are given as shown there. Fx equal to x upon L plus m and gx equal to x upon p plus q. And FOG equal to GOF. This is given to me, and then I have to say that what is the equivalent statement for FOG equal to GOF. When you read the question, what comes to your mind? That when Fx information is given, information about Gx is given, then it is easy for me to write actually FOG on X and GOF on X. So go methodically and first find FOG on X. FOG on X means F on Gx. So replace Gx by x upon p plus q and apply F later. And when you apply F, you will get x upon p plus q upon L plus m. You can simplify this and keep ready your expression for FOG on X. And that is x plus pq upon pl plus m. Exactly on the similar lines, I go for GOF on X. That would be G on Fx. Replace that Fx by x upon L plus m. And now apply G from outside. And when you apply G on it, it would be x upon L plus m divided by P plus Q. And then I simplify this and I will get x plus Lm upon PL plus Q. I have to use FOG equal to GOF, right? I do that exercise and I write x plus PQ upon PL plus M equal to x plus LM upon PL plus Q. That x upon PL is going to get cancelled, that I can see. But when I cancel that, I will be left with PQ upon PL, even that P will get cancelled, and then on the left hand side, I will have Q upon L plus M. Now when I look up there, Fx is given to be x upon L plus M. So Q upon L plus M would be nothing but FQ. Similarly, you do that exercise on the right hand side and you will realize that right hand side is nothing but G at x equal to M. So the correct option is nothing but B. Let us move to the next question. And the next one is that functions f and g are defined by fx equal to log 2 log x plus 2 divided by minus x to the base 100x and gx equal to fractional part of x. Additional information is composite function FOG exists, then the range of function g is, and then I have 4 options and the correct option is to be picked up. Now when you read this question, there are so many things involved. Somewhere FOG is involved, information about fx is given, that also looks complicated. The only thing what looks quite soothing is gx equal to fractional part of x. And the question is also about the range of function g. Mind you please, I have been saying this, that range of function depends on the domain and nowhere information about domain of g is given. So don't you think that to attack the question, that the range of function g is to be obtained, we will have to first be ready with domain of g. Also, something more comes to our help, and that is FOG exists. When would FOG exist? That F, when you apply, you will apply on gx. And where do gx values lie? They would lie in the range of g. Means domain of f and range of g must match. I hope everyone understands this part clearly. If FOG has to exist, then domain of f must be equal to range of g. And the question is regarding range of g. So don't you think we will have to find first what is domain of f? I mean, question looks complicated, but if you go step by step, then you will understand from where you have to start. So my steps are that I would work towards that how to find domain of f, right? So let us start. Now function f is given in terms of log, and the moment you see log there are some conditions on the base. base is 100x. Base can never be 1. That means x can never be 1 upon 100. That is my first condition. And also, log is applicable only when quantity on which you are applying log, that should be positive. And also, one more condition, don't forget that base has to be positive, and I have so x greater than 0. So let us work on the condition that log would be applicable only on positive values. So that 2 log x plus 2 upon minus x will have to be positive. Now denominator minus x is negative as x is positive. Means what? Now numerator 2 log x plus 2 will have to be negative. Use normal information about logarithmic functions, what we have seen before, and arrive at the point that log x to the base 10 is less than minus 1. See, base is more than 1. So, inequation sign will remain same, and hence x would be less than 10 raised to minus 1. That is equivalent to x is less than 1 by 10. So, we have gathered information about x. And what x stands for? Values of x are going to be in the domain of f. And now, let us get back to the previous part. FOG exists means the range of G is same as domain of f. And domain of f, that information we have already found. So, I can directly write from there that range of G is going to be that since I have mentioned x is less than 1 by 10 and x is greater than 0. So, my first part is open interval 0 to 1 by 10. And I have also mentioned that x not equal to 1 upon 100. So, that singleton set 1 upon 100, that particular singleton set, I will have to remove from that open interval. And that 1 upon 100 lies between 0 and 1 by 10. Don't forget that. And now I am ready with the range of function. So, my correct option is nothing but C. I hope you have understood it. Otherwise, you write all those steps, what I have written here, and after understanding every step, you write. And I'm sure then you will understand the crux of the question. Let us move to the next one. And the next one is, now graph is given. And I have to find f of fx. But information about fx is not given. It's only in the form of the graph. And question is regarding f of fx. Now, in my previous session somewhere, some similar graph we have seen. There also we have worked on how to find fx. So exactly on similar lines, we try to find here fx. I named main points as P, Q, R and S. S is the point where segment QR meets the x-axis. Now can you write certain things like point Q, that is 1, 1, point R, that is 2, minus 1. I can write slope of segment QR and that y2 minus y1 upon x2 minus x1 using that formula. I write that as minus 2. And from there I would be able to write equation of segment QR. And that is nothing but y equal to 3 minus 2x. Now y equal to 3 minus 2x, this is definition for QR, means this is definition for fx in the interval 1 to 2. So now I am free to write my definition of the function. Looking at the graph. Graph says that segment PQ is parallel to x-axis and it is at height 1. So fx is 1 throughout whenever x is between minus 1 and 1. And just now we have found that function's definition is 3 minus 2x whenever x is between 1 and 2 is equivalent to between points Q and R. That particular definition we are writing. So now my fx is ready. Correct? So from here we will be able to write f of fx. Our job is to write f of fx finally. Right? So f of fx would be f of 1 if your x is between minus 1 and 1. And it would be f of 3 minus 2x whenever x is between 1 and 2. Now understand this, that 3 minus 2x, where does it lie? That you will have to check whenever x is between 1 and 2. Now whenever x is between 1 and 2, you have to go towards 3 minus 2x. So multiply first by minus 2, in equation sign would reverse, then add 3 on both sides, and then I get that 3 minus 2x lies between minus 1 and 1. Means if I name that 3 minus 2x as t, then I know that t lies between minus 1 and 1, and I'm looking for information of ft. And that we have already written. F of t, when t lies between -1 and 1, is nothing but 1. So, I rewrite f of fx is 1 between -1 to 1, and also it is 1 whenever x is between 1 and 2. Means now I can combine straight from -1 to 2, and I will write in the combined form that f of fx is nothing but 1 throughout. Throughout means right from -1 to 2. That is the definition for composite function, FOF, f of fx means. Let us try one more before we end up the session. I move to next, and the next one is functions f and g. They are from R to R. Fx is given as 3x minus 7 and gx is given as 2 plus x. And question is that if f inverse or g inverse on x is equal to 3, then what would be corresponding value of x? Now when you read f inverse or g inverse, means what? You are talking about inverse of function. So recall whatever you have done in inverse of function. F inverse or g inverse is inverse of GOF. So first I will have to work on GOF. So use fx and use gx and go for GOF on x. GOF on x is g on fx. So apply fx, apply g, and that would be 2 plus 3x minus 7. So that leads to 3x minus 5. And if I call, say, 3x minus 5 as y, it is nothing but a line. And when you draw that line, you will realize that it is nothing but a bijection. When I say bijection, 1, 1 on 2. Injective and surjective. I hope you remember all these words. Now, since it is a bijection, I made sure first whether it is bijection or not. And now, since it is bijection, I know that inverse of GOF exists. See, whether it is given in the problem or not, it is our prime duty to see whether inverse exists or not. And inverse would exist only when it is a bijection. So I made sure it is a bijection. And now I am free to write some information about GOF inverse. So GOF on x, if I call that as y, which is nothing but 3x minus 5, I rewrite from here what is x. And it is y plus 5 upon 3. And it is GOF whole inverse of y. Now, GOF whole inverse of y equal to y plus 5 upon 3. This tells me that in place of y, I could have written t or u or x, anything. So, from there, I can say that GOF whole inverse of x equal to x plus 5 upon 3 also. I mean, it's a dummy variable. If you wish, in place of y, you can write x also. Correct. Now, GOF whole inverse is nothing but f inverse or g inverse. Means, indirectly, I have found now f inverse or g inverse applied on x would be nothing but x plus 5 upon 3. Now, go back to the question. Question says, if f inverse or g inverse on x is equal to 3, then what is x? Don't you think that x plus 5 upon 3 will have to be equated to 3? And that would lead to nothing but x equal to 4. So my correct option is D. Now, look at the variety of the question. Somewhere you are having in this last question inverse of GOF. In the previous questions, you had somewhere some composite functions also. So in this session, we actually had more of composite function. So when I come again in the next session, again there would be some variety. Till then, stay tuned. Bye. Thank you.